Alright, welcome. In this video we're going to be solving some differential equations that are not exact equations but could become exact equations if we hit them with an integrating factor. And I'm going to just kind of copy in these integrating factors that we have. So we saw, in the lesson that if the integrating factor is going to depend on t only, then it's going to be e to the antiderivative of my minus nt divided by m with respect to t. And if the integrating factor depends on y only, then it'll be e to the antiderivative of nt minus my divided by m with respect to y. Okay. So let's just jump in there and do one of them. So the first one is 3xy plus y squared. Yeah, I'll just copy it real quick. Okay. So if I was to pens out. If I was to compare my and nt, okay, well, this first thing is m, the thing that doesn't have the y prime on it. So my is going to be equal to 3x plus 2y, and nx is going to be equal to 2x plus y. And these are very close to one another, but they're not exactly it. So I'm going to need to get an integrating factor to make these the exact equations. Okay, my integrating factor, I'll just try the formula that's in t first. Okay, so mu would be e to the antiderivative of my minus nx. Okay, so that's 3x minus 2x is 1x. 2y plus y is 1y, all divided by n with respect to x. Okay, now this is n, so I'm going to, it's got x plus y in it. Okay, so this will work. So it's x times x plus y. I'll kind of cancel these off, anti-differentiate with respect to x. This is going to be e to the log x, and that's just going to be x. So now I'm going to hit both sides of this equation, multiply by x. I'll distribute to this thing and that thing. And so I'll have 3x to the 2, y to the 1, plus x, y to the 2, plus x to the 3, plus x to the 2y, y prime equals 0. Okay, and this will be an exact equation, right? Because if I check the partial of this with respect to y, that's going to be 3x squared plus 2xy. And if I take the derivative of n with respect to x, I'll get 3x squared, and I'll have 2xy. And see, that's the same, so I'm going to use the exact equations technique. Okay. I'll zoom out a little bit. And say that, okay, my solution, because this is the first one, my general solution is some sort of implicitly defined curve, f of x and y is set equal to c. And with fx equals this, 3x squared y plus xy squared, and fy equal to this thing, x to the 3 plus x to the 2y. Okay, so now we're just going to do some anti-differentiation to find out what this f is. Okay, so f is going to be an antiderivative for this with respect to x. And it's also going to be an antiderivative for this with respect to y. Okay. So I'm going to go in, anti-differentiate on x. That'll be an x to the 3 and 1 power of y, plus 1/2 x squared multiplied by y squared. And it's also going to be equal to, with respect to y, that would be x to the 3y. That's a good sign. And then 1/2 y squared, with the x squared still attached. Okay, I'm seeing that on both of them, so I know that's going to be my, my potential function or whatever. So my general solution is going to be x to the 3y plus 1/2 x squared y squared is equal to some constant. Had they given me an initial condition, which they did not, I could have actually plugged in on x and y to find the value of c, and that would give me a particular solution, but that'll be far enough for our purposes here. All right, the second one, I might just go ahead and cut. All right, this one would be the same story. You would take the partial derivatives with respect to y and with respect to x, and you see they're like kind of close, and they're not going to be, exactly the same. So I'm going to try mu equals e to the antiderivative. I forgot. No matter what with these, you've got to take my and x so that you can subtract them. So I forgot. My is going to be equal 3x minus 2y, and x is going to be 2x minus 1y. Okay, so I like the thought of taking, because of this x times x minus y, I think if I subtract my minus nx, I'll have x minus y, yes. Okay, so my minus nx is x minus y, divided by n is x times x minus y. So I'm going to see the exact same thing happen on this one. I know that my integrating factor is going to be e to the log x, and that's just x. Okay, and so I'm going to go over here, I'm going to multiply everything through by x. This looks remarkably similar to the first example, but it's all right. I'm going to say I did not put in the y prime, but it's right there. It's probably vanity, but yeah, there you go. That's better. Then I'm going to say, okay, now my is going to be 3x squared minus 2xy, and x is going to be 3x squared minus 2xy, I think almost exactly like it was before. But my thing I'm looking for is going to be an antiderivative for 3x squared y minus xy squared. This is just off by a negative or something. Okay, so but I can do these antiderivatives without too much trouble. That's going to be x to the 3, y to the first, minus 1/2 x squared y squared. And then over here I'll have x to the 3 multiplied by y, because x to the 3 is constant with respect to y, minus 1/2 y squared multiplied by x squared. Okay, so my general solution is going to be x to the 3y minus 1/2 x to the 2y to the 2 is equal to some constant c. Okay, now this one looks a little more interesting. It's got some trig in it. So I'm going to start by taking my partial derivatives. My is going to be, do I really need to do the derivative of this with the product rule? I guess I do, because they both have y's in them. So I'm going to take the derivative of x plus y with respect to y, and that's going to be 1, and leave sine y the same. Then I'm going to add in, leaving x plus y the same, taking the derivative of sine y with respect to y, and that's going to be cosine y. Okay, and x is going to be sine y. That looks the same. Plus 0. Okay, I'm just going to make sure I copied the problem right. X sine y plus cosine y, y prime. Yeah, and x is sine y. All right, well, oh, I get it. So what we need, we're going to want to divide by this x plus y, because if I subtract these things from each other, the sine y's are going to get killed, but I'll have that left. Okay, now, yeah, I see where we're going to want to go. I think we're going to want to have mu in terms of y only. Okay, so my integrating factor is going to be e to the antiderivative of nx minus my would be the negative of x plus y times cosine y, divided by m, okay, so that would be x plus y sine y. And we're going to anti-differentiate that with respect to y. So this is e to the negative antiderivative of cotangent y with respect to y. Man, we could, is it going to be log sine? Negative log sine? I don't know. Let's see. About the textbook, go to the table of integrals, look up cotangent. Little concerned, it's log of sine. Okay, so this will be negative log of sine. Okay, so if I was to make that, this would be 1 over sine. Okay, 1 over sine y is going to be my integrating factor. Because that would be sine y to the negative first for that negative. So 1 over sine y. But that actually looks like it might help a little bit. Okay. So now I'm going to actually distribute in my integrating factor, and then I'll get x plus y without the sine y, plus Okay, I'm going to distribute this, and I'll have an x plus cosine y divided by sine y is cotangent y. This is very concerning, but maybe I'm missing something. Yeah, I think it is going to work out. Okay, I think I must not have worked one like this in quite a while, so I'm going to say, okay, my general solution, this one did not come with an initial condition. It's going to be f, which is an antiderivative for x plus y with respect to x, which I might just do now. I'm going to say that's 1/2 x squared plus x times y, okay, plus some other stuff that will depend on y only. And that's where that cotangent of y is not a huge deal, though. I've got that over here, but not over here. So it's also going to be an antiderivative for x plus cotangent y with respect to y. And so with respect to y, an antiderivative for x is xy. And then, well, wait a second, I just looked that up. That's log of the absolute value of sine y. And, you know, maybe plus some stuff that depends only on x. Oh, well, here's that. Another color, but I'll use green. Okay, log sine y, that's that thing right here, the thing that depends on y only. And then 1/2 x squared, that's going to be the thing that depends on x only. So I've got this done. Okay, my general solution is going to be 1/2 x squared plus xy plus log of sine y is equal to some constant. And I think that goes far enough. No, it's not the type of one that we could solve for y explicitly anyway. All right, this next one's coming with an initial condition, so I know I'll be able to find a particular solution. Now I'm going to start the same way as always. I'm going to take my, and that's going to be 3e to the t, and I'll take nt, and that will just be e to the t. It's not exactly the same, but they're close enough. I think we'll be able to work with this. Okay, I definitely want to divide by this, right? Because if I'm subtracting these, I'm going to have 2e to the t, and I definitely want to divide by e to the t. So what I'm thinking is, I'm going to use the mu of t, and that's going to be e to the antiderivative of my minus nt is 3e to the t minus e to the t is 2e to the t divided by n with respect to t. Okay, this is e to the antiderivative of 2 dt. Okay, so that's e to the 2t. Okay. So I'm going to multiply both sides by this. Now, I'm just remind you, e to the 2t times e to the t, that's going to be e to the 3 total powers of t, right? Because we're multiplying two things with the same base and different exponents, we're going to add the exponent. So I'll have 2t plus an additional t is 3 total t's in the exponent of e. All right, but then over here, I'll have 3e to the 3t y plus t plus e to the 3t y prime is equal to 0. Yeah, and this is going to work out because the derivative of e to the 3t with respect to t being 3e to the 3t. Yeah, that's going to be it. Okay, so my is now 3e to the 3t, and nt is going to be 3e to the 3t. So this is exact, and I'm going to be able to find myself my solution. Okay. My expression that will give me my solution is going to be an antiderivative for 3e to the 3ty plus t with respect to t. And it will also be an antiderivative for e to the 3t with respect to y. Okay, shouldn't be too hard. Okay, this is going to be, with respect to t, I would divide by 3, right, to prepare for the chain rule. That's an antiderivative for 3e to the 3t times y with respect to t. Then here I'd have 1/2 t squared, and then I'd also have, with respect to y, that'd be e to the 3t multiplied by y, maybe with some stuff that only depended on t, like that. And so my general solution is e to the 3t multiplied by y plus 1/2 t squared is equal to some constant. But now I'm interested in actually finding out the value of that constant, so I'm going to go over here, and I'm going to t equals 0 and y equals 1. Okay. So when t equals 0, I've got e to the 0, y is 1, plus 1/2 of 0 squared equals c. Okay. So I know that means that my particular solution is going to be e to the 3t multiplied by y plus 1/2 t squared is equal to c, which is 1. Okay, that'll be my particular solution. Didn't have quite enough space to fit that all in, but it's all right. All right, number 5, and I think this is probably going to be the last one I have time for. School's out for the afternoon, and I'm really hungry, so I think I'm going to stop here and record the other 5 as a separate video. But so let's start by taking our derivatives. This will be my equaling 3x squared plus 2x plus 3y squared. And x, in this case, will be 2x. Whoa. Okay. Oh, but I like the look of this, right? Because when I subtract these, I'll have 3x squared plus 3y squared, and this is x squared plus y squared, so I do like our chances here. All right. So if I'm dividing by n, I need to use the mu of t, right? The antiderivative of my minus nt, so that would just be 3 times x squared plus y squared, divided by n is x squared plus y squared. Interesting. Dx. Right? And that'll just be, okay, e to the antiderivative of 3 with respect to x. This is unexpected. I don't see any exponential in here, so I'm kind of surprised that this is going to end up working this way. But it does look to me like that's going to be e to the 3x as my integrating factor. All right. I really hope this is right, because if it's not, I'm going to get really bad. X squared e to the 3x plus y squared e to the 3x. Y prime equals 0. Okay, these partial derivatives don't look super exciting. But this will be all right because I'm taking my. Equals 3x squared e to the 3x. Again, just 1 power of y. Oh, that's great. Plus 2x e to the 3x. And then with respect to y, that would be 3y squared e to the 3x. Okay. Then over here, in x, this is going to definitely require some product rule. I'll take the derivative of x squared and leave, okay, that's 2x e to the 3x. That's promising because I see that over here. Then I'll leave x squared the same and take the derivative of e to the 3x, which will give me the 3 I need. I was a little worried there. Okay, so with the chain rule, derivative of e to the 3x is 3e to the 3x. Okay. That was just the product rule bit here. With respect to x, that'll be plus 3y squared e to the 3x. Okay, that was unexpected that ended up working out. But, you know, I trust the work that we did to find that formula where the integrating factor was going to be e to the antiderivative of my minus nt all divided by n with respect to t. So, like, it did work out. It's very surprising. Not looking forward to anti-differentiating these two, and if I wasn't already, I guarantee you I'm stopping after this problem. The thing I'm looking for is an antiderivative for 3x squared e to the 3x times y plus 2x e to the 3x multiplied by y plus y to the 3 e to the 3x with respect to x, and it's also equal to an antiderivative for x squared e to the 3x plus y squared e to the 3x with respect to y. Now, there might be something I can do to make this a little easier. Over here, okay, I can make this easier by factoring out e to the 3x. Okay. And then when I anti-differentiate x squared with respect to y, I'll get x squared y. And then I'll get 1/3 y to the 3rd. Okay. Here, I'm just trying to think if there's any way around doing u dv on this. Yeah, no, that e to the 3x is really troublesome. I was thinking about factoring out the y and stuff, but like either way, that product is just so troublesome. I'm going to have to do a little bit of side work. But that's okay, that's what we're called to do, we can do it. Okay, I'm going to kind of zoom in, I'm going to write out what I'm interested in finding. That's just an antiderivative for 3x squared e to the 3x. With respect to x. And then I'm going to just hit on this and do integration by parts to find that. All right, there we go. Okay, u is going to equal e to the 3x, and dv is going to be, no, this one's going to require 2 iterations. All right, change of plans. We're looking up the antiderivative for this. We know that we could, right, because it's x squared, we could use isolate. This was backwards. I should have done dv equals e to the 3x because of isolate, right? Algebra before exponential. I was just excited to anti-differentiate 3x squared, but that wasn't going to help me at all. And then u is going to equal 3x squared. But then I know this requires 2 iterations of integration by parts, so I'm going to decline to do that and just kind of pull the antiderivative out of the air. And there it is, 1/9 of e to the 3x multiplied by 9x squared minus 6x plus 2. And that's, a little surprising, but, we could have gotten that using integration by parts twice. Really what I did is I went to Wolfram Alpha and just typed it in. Asked for an antiderivative for 3x squared e to the 3x. You got to be careful with your parentheses when you do that, but then that's going to be an antiderivative. That will work. Okay, I'm also interested in an antiderivative for 2x e to the 3x. Now I'll probably do that. I'll do that one by hand. How about that? I mean, I'm not scared of doing integration by parts multiple times. I just don't think it's worth you watching me do on this video. So what was it? It was 2x e to the 3x with respect to x. Isolate algebra before exponential, so I'm going to let u equal 2x and dv equals e to the 3x dx. So that du is 2 dx and v is 1/3 e to the 3x. Okay. We know that the integral of u dv is equal to u times v. Minus the antiderivative of v du, so that'll be 2/3 of the integral of e to the 3x dx. Okay, and so it's going to be 2/3 x e to the 3x minus, I'm going to divide by 3 when I anti-differentiate e to the 3x with respect to x, so that will be 2/9 of e to the 3x. Okay, so that's going to be my antiderivative for that one. So I'm going to zoom all the way back out and just kind of use these results. Have it for reference. Let's scoot that over here. We can use that in a second. Now, I'm going to say over here, we need to have this thing, well, all attached to it. So, yeah. So I'm kind of envisioning me actually distributing this in, so it's x squared e to the 3x, still multiplied by y. Okay, then I'll distribute this over here. 1/9 of -6 will be minus 2/3 of x e to the 3x, and that's a good sign because I saw that 2/3 x e to the 3x, plus 2/9 e to the 3x. Now that's concerning. Hold on. Where have I made an error? I've made a sign error, so I can just tell because I'm supposed to have... Oh, wait a second. No, that's still part of this one over here. Okay, no, we're good. Okay, plus 2/9 e to the 3x. Then I've got this one, and I still haven't even anti-differentiated that one yet. I'm not going to be able to fit this in. That's troubling. Okay, it'll be all right, though. Because the antiderivative for this 2x, that's in green. That's plus 2/3 x e to the 3x minus 2/9 of e to the 3x. Okay, so these are both gone. That's interesting. They kind of like canceled off in there. And then I'm just left with, I bet there was something to be seen there. Anyway, Antiderivative for this with respect to x will be 1/3 of y to the third. E to the 3x. Yeah, there was, okay, 1/3 y to the third, e to the 3x, x squared y, e to the 3x. Yeah, I'm seeing the same thing over here. Okay, so my general solution is going to be x squared e to the 3x multiplied by y plus 1/3 y to the third e to the 3x. That's equal to 0. That was a wild one. Okay, I just had twists and turns the whole way through. It's definitely going to be all for this video. I'll come back and record the rest of the solutions probably tomorrow or something, but, you know, thanks for watching.